Good afternoon, everybody. Just giving everybody a minute to join. All right, I think most people have joined. Just let me check the participants list. I hope that everybody got my message and that there's no one sitting in the tent waiting on me, because I saw the weather today, just decided to have it online so that people could go home or at least not be in the tent while the rain is falling. So we're going to begin. Just note that if you are messaging in the chat, I will not be able to see it from the time I start presenting my screen. So just let me know if you can hear me clearly before I share my screen.
Yes, ma'am. I can.
Yes,
ma'am.
please.
I can hear you clearly.
All right. Yes,
ma'am.
Thank you. This is actually better than you being under the tent.
Well, unfortunately, I don't have the authority to switch it entirely online. I think it would just be extenuating circumstances. So it's just for today. I have some information for you before I start. Your midterm is going to be given to you in week 7, which is, what date is that? Hold on. Week 7. This is now week 4, 5, 6, 7. So the week of October the 30th is going to be given to you not during class time, and you're going to have an 8-hour window to access it, but you're going to have 2 hours to do it. It's going to be 40, supposed to be multiple choice questions, but I'm still waiting to get final approval. But it's supposed to be 40 multiple choice questions. And I am thinking to make it a bit easier for those of you who work, I will either open it from maybe a Friday evening for the 8 hours, or we could also do it a Saturday afternoon. So I want to consider those who are Saturday Adventists as well. So it will either be maybe from Saturday, like let's say 2 p.m. Or from Friday, let's say from like 4 p.m. or something like that. So I'm gonna.
Good afternoon. Sorry to cut you, but you kind of cut out for me, so I didn't understand what you said. All I picked up from was when you said from Saturdays you want to take into consideration 7 days Adventist, but I'm not sure what you mean because you just kind of dropped out.
Okay, I was speaking about the midterm. So the midterm is going to be the weekend of the 30th, and I was explaining that you have an 8-hour window to access it, but it's going to be timed for 2 hours. So once you start it, if you start it at 2 o'clock, you have to finish it by 4 o'clock, but you'll have, let's say, between 2 o'clock and 10 o'clock to be able to access it to start. I was saying that the options that I have was maybe to start it from maybe, let's say, 4 p.m. on Friday, the 30th, or do it on November the 1st, the Saturday, maybe from, let's say, like 2 or 3 p.m. Because I was saying I would try to take into consideration the 7-day Adventists, but I will put a poll and you can choose what time period would be best for you. But I'm just giving you notice of that. The topics that will be covered would be, if you look in your course outline, it will be all of Unit 1 and the first 3 topics in Unit 2. And I'll outline for you I'll put an announcement in the classroom exactly what those topics are so that you can be clear. So today we want to try to finish, but any questions about that before I move on? Oh, and I also said there's going to be 40 multiple choice questions. That's the other thing I said. So any questions?
No, ma'am.
Check.
So you are just going to let us know precisely when the midterm is. It's gonna be 40 questions. We understand that, but you still gonna have to let us know exactly what date it is going to be done.
Yeah. So what I was saying is that I will kind of give you the options. So I'm going to create a poll online, and I will put the 2 options that I think are best, and then based on who chooses, how much of you choose which option, then I would let you know what's the specific date. So my 2 options for now would be Friday. I would say between, I'm going to say maybe, let's say 3 p.m. on Friday until 8 hours from them, or maybe 3 p.m. on Saturday. Those are the 2 options. So when I make the poll, you would just choose and you will let me know what you prefer.
Okay, no problem.
Right, so the next thing too is the structure of the midterm is such that they do not want you to collaborate. So, well, that's obvious because you're at home. And it will be entirely online. It's not a case where you will write down your answers and you will submit, but you'll be clicking the answers on the screen live. Everybody's not going to get the same questions. And once you move on for a question, you cannot go back to it. So I'm just letting you know that up front.
I'm sorry. Sorry, I didn't mean to interrupt. You said you have 2 hours to complete it?
Yes, please.
Okay.
Yeah.
So you can use calculators, right?
Yes, you're allowed to use calculators. That's not a problem. Well, I can't exactly tell you not to use a calculator because I'm not home with you. So using calculators will not be a problem. All right, let me just check the chat before right, so nothing important. Right, so as I said, for those who have just came in, and I know that there are going to be people who message me and asking me where the lecture is and where there's no lecture, I would like to encourage you, if you don't already, let your KPL mail come to your phone so that when they post announcements that you can see it. Because seeing how these classes are going, based on last class and the water coming through the tent, anytime it starts to rain for the whole day, I'm going to have class online. But I can only do that if that happens. So don't expect that we can do this every week. So just letting you know that. But just say something, just interrupt me if you have a question, because like I said, I won't be able to see for those who might have just joined. So I'm going to present my screen. And this is the point where we were at. I really want to finish this lecture today and I want to start unit. No, this is not where we were at. We were here. Right, I really want to start the next unit so that y'all can get to that in your tutorials as well. So we're looking at scientific notation, and a positive number x is said to be written in scientific notation if it's expressed as follows. X is equal to a multiplied by 10 to the n. Really all that means is whatever the number is that you're looking at, we write that number to using only the first number as your whole number, multiplied by 10 to however many times it takes us to jump to that number. So this may sound a little bit confusing, but I'll show you what I mean. So for instance, if I'm going to work backwards in these examples. So if I have this one here, and I have 240. Now this is 2,400,000. What I need is that I need to get it in this form. I need to have just a whole number. So, and I need it to just be a one digit number. So by that I mean my number should start like this, 2 point something. So I really only want the first non-zero digit to be in my ones column then. And then the rest of it can be the decimal version. So I only want one value. I don't want any tens, as in I don't want 24 point anything. I just want the first non-zero digit to be in front of my decimal point. So it will be a little bit more clear as I go on. So that means my answer should start as 2 point, and then it will be 4. And then you will have all those zeros, but it's not necessary to put those, because after a decimal point, if you just have a series of zeros, they're insignificant. Just like how, if you think of it, if I have 2.40, that's the same thing as just 2.4. So those zeros are not important. However, we can't just change this sum. Sorry, we can't just change this to this just like that. What we need to do is, right now as it stands, let me rub out some of this. So right now as it stands, this number here above does not have a visible decimal point. And what you need to do is that you need to move this invisible decimal point. Now, if you see a number that does not have a decimal point, the decimal point is right here at the end. It's just we don't write it. Just like how if we had to write, sorry about that. Just like how if we had to write, let me scroll up. If we had to write $15, for instance, that $15 is the same thing as 15.00. Just we don't write the zeros and we don't write the decimal point, but you still know that this is equivalent to $15. So a decimal point always comes at the end of a whole number. So just bear that in mind. So there's this invisible decimal point here at the end. And what we need to do is that we need to move it from here all the way to where we want it to be in our answer, which is here between the 2 and the 4. So I have to jump and I have to count how many times I have to jump to get from here to there. So if I jump, I'll get 1, 2, 3, 4, 5, 6. So when my answer then will be 2.4 multiplied by 10 to the power 6. Now this part here will be multiplied by 10. That's standard. The only things that vary are what this part here is going to be and how many times you would have jumped. Does everyone understand what I just did?
Not quite, ma'am. You could repeat it, please. Not well, ma'am. Just to be on the safe side, yeah. Repeat it for me, please.
All right, let me do another example. So, what if I had? Let me rub this out. What if I had 3 point? No, let me not use a point there. Let me use 381. Let's say I have this number and I wanted to put this into scientific notation. I will start by writing down what I want to get, which is 3 point, and it was explaining your point should always go after the first non-zero number. This is the first non-zero number, so I'm going to write it back as 3.814. Like I said, these zeros here are not important. And it's going to be multiplied by 10 to the something. I just don't know what the something is yet until I figured out how much times I have to jump to get my point to go from where it currently is now, which is here. As I said, for any whole numbers, the point is, if you don't see it, it's at the end. So I have to jump and see how much times it will take me to jump from here to here, where I want it to be. So I have to jump 1, 2, 3, 4, 5. So that'll be 3.8 by 10 to the 5. Do we understand?
Get it?
Yes, ma'am. Thanks.
Please.
So
Yes, please.
good. So the reverse also works.
Yes.
Now, if you have, let me not rub that out. Let me change that. This, your answer comes out to have a positive power if it is a whole number that you are like this, a whole number that you're converting to scientific notation. However, if you have a very small decimal or any kind of decimal really that you're converting to scientific notation, the power comes out to be negative. So when it's a large number, a large whole number, your power comes out to be a positive one. But if it is a decimal number or a very small number, a number that is smaller than 1, your power comes out to be negative. So let me show you what I mean by that. If I had, let me go on Jamboard. Don't have any here. Hold on. I don't know where that is. So there we go. All right, so if I had 0.0000453, for instance, so this is a decimal, a number less than 1. To do this, I want to do the same thing, find the first non-zero number, which will be 4, and I want my point to be here. So my answer should look like this, 4.53 multiplied by 10 to the something. But because I am jumping in the opposite direction now, to get from my point here to my point here, I have to go this way. 1, 2, 3, 4, 5. So my answer will be to the negative 5. So basically, if this number was the other way around, suppose I had a very large number that was this. 1, 2, 3, 4, 5. Let's say I had this number here at the bottom, and I got the same answer, 4.53, because we know we want our decimal point to be here. If I jumped, I would have jumped this way, 1, 2, 3, 4, 5, and I would have gotten it by 10 to the positive 5. So if I jump going this direction, my answer comes out to be positive. My power comes out to be positive. If I jump in this direction, then my answer comes out to be negative. So an easy way to remember that is, if the number is a very large whole number, or any kind of whole number really, your power should come out to be a positive. If the number is small, if it's less than 1, if it's a decimal, then your answer should come out to be negative. So let me just do one more example for you. What if you had, I'll give you some hard ones, 10.35. And let's say you also had 0.681. So if I had to, let me do one more. Let me do 365.12. So if we have these three, should do one more, hold on. Let's also do, let's also do 1.00086. All right, so if I do the first one, remember all I need is that I need to have the first non-zero number, which is here in my ones column. So that needs to shift a place. So I really want my decimal point to be here. So my answer will be 1.035 multiplied by 10, and I have to figure out 10 to the what. So my point originally was here, and I need to move it here. So I would have only jumped one time in this direction. So that will be 10 to the 1. Right? So even though this is 10.35 and part of it is a decimal, you still have a 10. Right? So you still have a whole number portion. This number is still greater than 1. Once it's greater than 1, your power has to be positive. Right? Once it's less than 1, then your power will be negative. So let's call this number 1, number 2, number 3, number 4. Let's do number 3 now. So we have 0.861. I know that my point should come off the first non-zero number, which is here. So my answer should be 6.81 by 10 to the something. And in terms of what it should be, I know I have to jump this direction once. So this one will be 10 to the negative 1. Right? And again, this number here is less than 1 because it's 0 point something. Do we understand the difference between number 1 and number 3?
Yes, please.
Yes, ma'am.
All right. This one here, anybody can tell me what they think the answer will be. It'll be 10 to the what?
10 to the 0.
Very good. Because we already have it as the first, we already have the first non-zero number in the ones column. So that's already in the placement it should be. So this will be by 10 to the 0. That's correct. That's a 0, sorry for how that looks as I enter the screen. The last one now, we'll be jumping, we know we want our points to be here. So our answer should be 3.6512. And we jump in 1 2 times. So my answer should be by 10 to the positive 2, because this number is greater than 1. All right, so good, I think we understand that. your answers that are given here. Oh, so we also have to learn.
Put back that screen, please. Thanks.
No problem. So we also have to learn how to go from the question being in the scientific notation form back to the expanded figure. So hold on.
Wait, ma'am,
Yes, sis?
you lost me a bit. The screen that you had before, you had 3.65. 3.6. Was that? Oh, that's it. Okay,
I didn't. Mhm.
thank you.
Okay, no problem. So we also have to know how to go. Let me do another screen. Let's say give you a question that is already in scientific notation. Let's say this is by 10 to the 4. We have to know how to go from this to being the expanded figure. So what you would start by doing is you'll start writing your number, 265. And this tells you you have to jump 4 times. And if you have to jump more times than you have digits, and these would be my digits, then you just put zeros as placeholders. So right now I know my point was here, and I know I have to jump 4 times, so I'm gonna jump, and in terms of knowing which direction to jump, if it's a positive number, you have to jump this way because you need to add on zeros behind here. If it was a negative power, you know you will have to jump the other way because your zeros will come in the front and a decimal point. So for a term that has a positive power, you're jumping that direction. For a negative power, you're jumping that direction. And just to make it clear again, for a whole number, where if you have a positive number, this must have been a whole number, your decimal point should come at the end of your number. So that's where you jump that direction. If it was a negative power here, then you would jump this direction so your decimal point can come at the front of your number, like 0.35 or 0.006, right? So let me just show you how that question will be done. So in this case, we have to jump 4 times. So I know my point was here. So I'm gonna start here also. So that's 1, 2, 3, 4 times. So when I jump 4 times, I know my point comes here, and I have to fill in here with zeros as placeholders. So therefore my answer is 26,500.
Ma'am,
Yes, please?
missing the one is
Oh, thank you. Yes, you're correct. Sorry, I missed that there was a 1 there. Right, so that'll be your answer. All right, so that will be your final answer for that question. Let's try another one. Can I move from the screen?
Yes, ma'am.
Ma'am,
Right, so what? Yes, go ahead.
can I just leave the point at the end? I don't have to put the decimal point at the zero?
No, because when we write our whole numbers, normally we don't write it with a point at the end. It's understood that it's there. So there's no need.
Thank
Right?
you.
I only put it there to show you that it was transferring the point there, but we don't actually write it at the end. All right, so if I was doing, let's say, 3.52, I mean multiplying that by 10, let's say to the negative 4. No, let's do to negative 3. So we have to jump, and we know we want the decimal point to go this direction because this represents a decimal number, a number that's less than 1, and therefore our point should come ahead of this number. So we're going to jump, and we're going to jump 3 times. So I'm going to write it back over here, the 3, 5, and the 2. And I know I'm starting to jump from here. And I'm jumping in this direction. So I'm going to jump 1, 2, 3 times. And I'm going to put my 0 there as a placeholder. And my point goes here. So my answer will then be 0.00352. And I just put this 0 here, which would have been there as a placeholder for the ones column, because we could write 0.00352. That's also fine, but it's just standard to write it like this. All right, so I think that is pretty clear. We're going to move on now to the next part. So we have questions here. Let me write about some of this. What is that key happening?
Let me see.
Oops. Someone has a mic. Can you please turn it off? Okay, so all right, so we have a question here. We've been asked to calculate this sum. And just remember, anytime you have to do these, you can just put them, work out the top. So you'll work out this section here and work out the bottom and then get your answer. But there's a way that you can actually put this straight into the calculator. But there's also a way that you can work it out using the powers that you have, because all of this, in this particular question, all of the numbers are already in scientific notation. So what you could do is that you could change it so that you use the initial part of each question, each part of the sum that's in scientific notation. So by that I mean, I can use the 4.6 here, the 1.97 here, and the 2.91, and I can write those back in a sum. But I can then also combine all of the powers, all of the numbers, all the 10 to the powers. I can combine powers of 10, right? As long as they're all powers of 10. So that sum is rewritten as the 4.6 from here, multiplied by, and the reason I'm multiplying again is because if you look here, you will see that there are brackets. There are brackets which tell me I'm multiplying this one by this one. So I'm going to multiply that 4.6 from here by the 1.97 from here, 0.697, sorry. And I'm going to divide it by the 2.91 from here. And then I'm going to multiply that, and I'm going to combine the powers of each of the 10s. And remember, I can only do this as long as each of them are already in scientific notation, so they're all raised by 10 to the power of something. So I'll combine those, and that will be, you use the same rules as for powers that we normally do. Because remember, anytime you have the same base, when you're multiplying, you add the powers. When you're dividing, you subtract the powers. So the same base we have in this case is all 10. All of them are to the base 10. Excuse me. So that means I can put them all together, and I can, the ones that I had to multiply here, which is this and this, I can add those powers together. So there'll be minus 4 plus 22. But then I have this one here that is dividing, right? Because it's at the bottom. So then I can take away that power. So when I'm taking away that power, me write this a little better. Hold on. Right, so when I'm taking away this one now, I have to take away the full power. The power is negative 18. So I have to take away brackets. Let's see if we can get that to fit on. Brackets, negative 18. That's supposed to be 8. But it won't let me. Let me see if I can put it at the bottom. Maybe that make me feel a little easier, or write a little smaller. So just one more time. It's 10 like minus 4 plus 22 minus negative 18. Okay, so all I did, one more time for anybody who may have confused, is that I put the first parts of each of my sums that are already written in the scientific notation, I put them back in the same order that they were, the top two multiplying, the bottom one dividing. And then, because these are all multiplied by 10 to the different powers, they all have the same base, which is 10. I can just write 10 once and I can combine my powers. And I have to remember that when I'm multiplying my, if I'm multiplying anything that has the same base, any indices that have the same base, I add the powers, which is what I did here. And when I'm dividing by something that has the same base, which is 10, I subtract, which is what I did here. And I had to subtract a negative 18. So when you're working this out, you would put this part here in your calculator. The answer here is 2.7. And then you will just work out this part over here. And if you have to do this in your head, we know that these two negative signs will combine and give us a plus. So this sum will really become 10 to the power of negative 4 plus 22 plus 18, which would give us a total answer of 36. So my final answer is given here, which is 2.7 multiplied by 10 to the 36. Okay. Any questions about that?
Mom, you said you get 36.
Pardon?
You said you got 36.
The answer they're given is 36. Let me actually,
Me to talk. Okay.
Yeah,
Thank you.
no problem. All right, so part 4.
Huh?
Pardon?
Someone is asking in the chat, why are there two negative signs after, or someone answer them?
Oh, okay. It's because we're taking away. Remember once we're dividing, and we're dividing here. This line here represents that we're dividing, and once we're dividing, we subtract the powers once we have the same base. And remember, all of them are multiplied by the base 10. All right, so we have part 4. We're gonna look at simplify and write the answer in scientific notation. We're adding this term to this term. So it says first you write each term to the highest power and then simplify. So hold on. Trying to see if there's an easier way to do this. Okay, this is the easiest way. So whichever of your two terms here, given here, and let's look at the difference between this question that we're doing now and the one that we just did. Now, it was easy to join all of our powers together over here just because they were multiplying and dividing, right? You cannot do that if we're adding and subtracting. The rules of indices only apply to multiplication and division, or being raised to the power of something else. They don't apply to adding and subtracting. And this particular sum that we're doing, we're adding and subtracting. So this sum here, We're adding and subtracting. So what you will need to do is to be able to just add those together without putting it in your calculator. And let me just say, if you decided to put this in your calculator, which you entirely can, you will need to help the calculators to do BODMAS because it doesn't always. Sorry, hold on a second. Sorry about that. Let's go back. Right. So what I was saying is that because of the fact that we are adding these together, if you want to add them together, you need to make sure that both of these terms are to the same power. Both sets of scientific notation are to the same power. So that means you need to make sure that both of these is to the higher power. That would be the easier way to do it. You could also put both of them to the lower power, but it's a little easier to put both of them to the higher power. So I want that this one here that is raised by 10 to the 4 will be reflected also in this one here. So I want to change this term so that it's also raised by 10 to the 4, because once they're raised to the same power, we can just go ahead and add them together. So to do that, and what I would do if I were you, the working here is a little bit different. But what I would do for the 1.5 multiplied by 10 to the 3, if I know I want that to be 10 to the 4, then it means that I need to jump in this direction. If I jump in that direction, that would increase my power of 10 by 1. Okay, so then it will end up getting 0.15 by 10 to the 4. If I had to jump in the other direction, if I had to jump in this direction, then that will become 1.50 multiplied by, sorry, not 1.50. It'll become 1.5 multiplied by 10 to the 2. So in this case, if you are jumping to the left, you are creating a larger number, and therefore your values here at the front will have to decrease to compensate. So basically, whichever direction, think of it as opposites. So look at it this way. Hold on. Let me put about 15 by 10 to the 3, 10 to the 2. Think of it as opposites. If I want to increase the power here by 1, if I'm adding on 1, then they have to go in opposite direction. So if this increases that way, then this should increase that way. If I want, by that I mean, if I want to increase this by 1, think of it as a number line, like how you have 1, 2, 3, 4. If I'm going this direction, if I increase it that way, then my point should go the opposite way to compensate so that the sum still remains equivalent. Same thing here. If I want to reduce this power here to 2, I'll be going this way, and therefore to compensate, my point will be going that way. Does that make sense?
No.
I could explain one more time.
Sure. So I'm trying to say, if you're, let me go on Jamboard. Let's say I have, let me use a different number. So let's say I have 66.3 5. And let's say I have that by 10 to the 3. Let me use a different number. Let me use 10 to the 5. And I want that this term is written by 10 to the 6. That means I'm adding on 1, and I'm increasing my power by 1, which means I'm adding on this way. When I'm putting an arrow for this direction, I'm adding on 1. I am looking at it as a number line. Not number line, let's say this. Right? And same thing for negatives, and so on. But when I say I'm going this direction, I mean I'm going from 5 to 6, right? So I'm adding on, I'm going that way. So to compensate this term here at the front, the point must go in the opposite direction at all times, right? So my point must go that way. So if I want this to become 6, then I need to move my point backwards, and then now my point will go here, and my term instead will be 0.635. So when I increase my power, the term on this side, I must go backwards. So if this is going in the forward direction, if I'm adding on, I need to move this decimal point so that this side here gets smaller. So if you look at the difference between these numbers, this one at the top is a larger number than this number here. So for an easy way to say it would be, if my power is getting bigger, my number should be getting smaller. So that should tell you where the point goes. So alternatively, is not to say that I turned it into 63.5 because that'll be getting bigger. Obviously 63 is greater than 6. And at the same time, 0.635 is smaller than 6.35. Alternatively, if I had, let's say I have 5.7, and I had that multiplied by 10 to the 2. And I wanted this instead to be 10 to the 1. I'm trying to make this term here smaller, which means to compensate, I have to make this term on this side bigger. So I need this point to go in that direction so that this becomes 57. So I just move the point back once. So the point moves here, which is the same thing as just 57. Do we understand the difference between the two? You can think of it almost like a seesaw, like a balance, right? So if I give you a term, let's say I give you 7.83 multiplied by 10, somebody else has on their mic again, multiplied by 10 to the 5. So right now, imagine this is a seesaw and it's a balance, right? If it is that I want the power of the 10 instead to be 10 to the 6, if I leave this part here, if I leave that at 7.36, my seesaw will be off balance, right? One side will be heavier than the other. So to counteract that, what I need to do is that I need to make this side over here smaller. So what I would do is that I'll move my decimal point backwards so that when I jump, I saw the amount of times I jump is equivalent to how much I need to increase. So if I need to increase just 1, if we're going from 5 to 6, then I will only jump 1 time from here to over here. So then when I jump my 1 time, my point will be here instead, and this will be instead 0.7836 by 10 to the 6. I'll try one more question. What if I gave you, let me do one with a negative. So let's say I give you 1.34 multiplied by 10 to the minus 2. And I wanted it to be by 10 to the minus 3. So, can anybody tell me which direction they think I would jump? If it's negative numbers instead?
To the right.
Jump into the left.
So let's look at this side here.
I'm jumping to the right.
Let's break it down. Here might be a minute.
You see?
Sorry, I'm looking at the wrong thing. So if it's a case where, and remember for positive and negatives, it works a little bit different. This term, this number here is bigger than this one. When we look at negative numbers, we have 0, this is -1, -2, -3, -4, and they're going in order of size, right? So the smaller the absolute value, which is the value without the sign of a negative number, the larger it is. So that means if I'm going from 2 to 3, this side here is actually getting smaller. This side is getting smaller. So that means that if this side is getting smaller, over here it should be getting larger. And if I want it to get larger, I should be jumping to the right. So my answer should be 13.4. Is there anybody who's unclear about that?
Someone in the chat is asking if you do it one more time.
All right, let me do a different example.
Ma'am, the reason why you jump only once is because the reason why you move the decimal point only once is because you're moving from -2 to -3.
Yes, please. So let me do one where I'm jumping more than once.
Okay.
Just 1 second. So let's say I wanted, let's say we had 3.071 multiplied by 10 to the, let's say -3. And let's say I wanted it to become 10 to the -1. Is my power getting larger, smaller?
Larger.
Larger. So if this side over here is getting bigger, then it means this side needs to get smaller. So my point should move in which direction?
To the left?
To the left, ma'am. Yeah. And how many times will we move to the left?
2.
Twice. 2 times.
Correct. So I will jump 1, 2 times. And because obviously I don't have anything here, I'll use 0 as a placeholder and my point will go there. So my answer will end up being 0.03071. And that's the way it works. So let's go back to the actual question that we were doing now, which is here. And what I was trying to explain, let me rub this out. Right, so what I was trying to explain was that for this sum, what you want to do is that you want to change both terms to having the same power on the 10. So if one is to the 3 and one is to the 4, you're always going to put it so they both are the larger power. So this term then will change So that is 10 to the 4. So the 1.5 is currently by 10 to the 3, and I want it to be by 10 to the 4. So if I made this side here bigger, I'll make this one smaller. So my answer will be 0.15 by 10 to the 4. Once I have both of them to be 10 to the 4, I can now add on this to the 6.3 by 10 to the 4. And once they both are raised to the same power, then I can just go ahead and add these values. So my answer will become 6.45 by 10 to the 4. All right. All right, so let's try another example. Just one more quickly. I'm going to do one with a negative. What if I gave you, let's do 10.5 multiplied by 10 to the 6 minus 3.1 multiplied by 10 to the, let me change this. Let's change this instead to being 2, and let's change this to being minus 1. All right, so in this case, which power would you change? And change it to what?
-1 to 2.
Correct. So let's look at our number line again. Let's see how much times we will have to jump. So remember, our 0 is in the middle. Your negative powers go underneath. Your positive powers go at the top. So let's look at how many times we will need to jump. We will need to jump for -1 all the way to 2. So that is 3 times, correct? Everybody's in agreement? You understand what I just said?
Mhm.
Right. So I need to increase this power here by 3 so that it will match the 2 that is here. So I'm going to just do the 3.1 by 10 to the -1. And I want this to be 10 to the 2. And like we said, we're increasing this one. So if I'm increasing this side, I know I need to decrease this side. So my point should go in that direction to the left. So I'm going to jump 3 times, just like how I jumped here 3 times. So that is going to be 1, 2, 3. My point is going to be here, and I'm going to have to put some placeholders. So my answer is going to be 0.0031 by 10 to the 2. So now I can work out my sum. Now I've got my answer, and my sum will now be 10.5 by 10 to the 2. Take away 0.0031 by 10 to the 2 as well. And if I take these 2 away now, since these are both the same, I don't have to worry about these. I'll just take away the beginning part. Let me work out what that is. So 10.5 minus 0.0031. And that answer is 10.4969 multiplied by 10 to the 2. Now, if I give you these questions on a tutorial or in the exam, I will more than likely give you something that when it works out, you can work out this part, like the subtraction thing. So you can work out in your head instead of having to use a calculator. So just bear that in mind. But I made this up on the spot, and therefore that's why it became a little bit more difficult to have to use a calculator. I was mentioning to you that if you decided to do this sum straight in the calculator, which I guess you can, but I'm supposed to teach you the right way, you would just need to make sure that you use brackets. Somebody's mic is on, please turn it off. So you need to make sure you use brackets around the parts that are multiplication, because you know Bodman says that we have to multiply first. So I will have to use brackets around here and around here, right? So just remember that. If you don't, you will get a completely incorrect answer. All right, so moving
Please
on.
go back to the other screen.
All right.
Okay. Thank you.
Okay. All right, so next part. Ordering on a real number line at absolute values. I kind of went through this just now a bit, but it means, okay, we can go through it briefly again. Just ignore this. I don't know why this is upside down, but that should be a right side up one. So whenever you're doing your number line, just remember 0 is also always in the center. To the left are your negative numbers that look like they're increasing, but they're not. To the right are your positive numbers that are actually increasing. And when you do your number line, increasing values go this way, whether they are positive or negative. So when you do your number line, obviously you know 1 is more than 0, 2 is more than 1, 3 is more than 2, 4, and so on. So that's what I mean by increasing values go this way. But when you do the negative side, even though the numbers are getting larger, and when I say the numbers, I mean just the 1, the 2, the 3, the 4. We call those absolute values. So when you look at a negative number, let's say I have negative 2. This is a negative 2, but the absolute value of this is just 2. The absolute value means the value given, not taken into consideration the sign. So when I look at my negative numbers, it looks as if my absolute values are getting larger in this direction, but that's not the case, as I just explained, because increasing numbers go, like I said, that way. So that means -0 is more than -1, -1 is more than -2, -2 is more than -3, and so on. And an easy way to remember that, because I know some people get a bit confused with that, is I don't know if you would be able to remember, there was a point in time where people used to do data plans, and the data plan would come on at a particular time every single month, or every single week, or however long the renewal takes. And sometimes even if you didn't have the money on your phone, for instance, it was still deduct the cost of the data plan. So you might come and see that your balance, for instance, would be -$5, right? And if your balance is -$5, that is clearly less than 0. If your balance is -$1, that's clearly less than 0. And for that reason, we need to remember, or even if your balance was -5, that means you have even less money on your phone than if you had -$1. So that's just to explain that the smaller the absolute value is of the number, the larger it really is in terms of the size. So negatives just represent the absence of something. So if you understand that, you should understand why it is that the smaller absolute value means a larger number. -1 means the absence of 1. So let's imagine it was some object that you have. Let's imagine it was oranges. So -1 means I'm missing 1 orange. -2 means I'm missing 2. -3 means I'm missing 3, and so on. So that means if I'm only missing 1 orange, in total, I technically have more than the person who's missing 2. I have more than the person who's missing 3, and so on. So this is the largest here, and these would all be smaller. Everybody understands what I mean by that?
Yes, please.
Okay, great. So let's go on to understanding absolute values, and we'll rub all this out. So just to clarify, if you have -$5, you're richer than the person who may have -$30, for instance. You're missing a lot less than they are. And that's the reason why the smaller absolute value, which is just a number by itself without the negative, represents a larger number in negative numbers. So we have from the line, it is clear that any number that is to the left of another number is less than that number. We write, for instance, 1 is less than 4. I know that from primary school and up, people tend to confuse these symbols. An easy way to understand them, because even sometimes I forget what they are. I can't, for instance, I personally can't just look at them and figure out which one is more than or less than. What I do is I think of it almost as like an alligator mouth. So this side over here, let me use a different color. If I have A and I have B, the side that is open, which is this part here, I consider that like a mouth. So where the mouth is open to is larger than where the mouth, so right, so wherever the mouth is open to is the larger value. So then I can read this now and I can say that A is less than B. Now, if you know how to read them just like that, that's entirely fine. That's great even. But I know some people struggle with that. If I had this one now, for instance, go ahead.
I have an easier way because my son is now doing less than and greater than. And what the teacher said is, if you look and you see the L for less, that is the same way how the sign is for less than. So you use the L for less than, and then you know the other one is greater than. I hope you understand.
Yes, that's fine.
Good.
Yeah, there's several ways to remember it, and it works for different people. This one just happens to work for me. I've heard all those before, but to me, I still prefer to look at where the mouth is open to, and that tells me, for instance, that B is greater than C. But however you do it, that entirely works for you. If you want to use the L for less than, that's great, and that's fine.
Ma'am, when his son is here, he's actually paying attention to the class. So when he put he's like, Mommy, your teacher now teaching you this? Mommy, my teacher taught me this ever since. When the mouth is open to the number, the teacher said it is the alligator eating the bigger number. So he here like in the whole frenzy. So it's the same concept that you know use. My son is here saying the same thing.
Okay, great. Well, yeah, I mean, yes, we are taught these things in primary school, but as you get older and you learn more, and I know people forget things, it's still good to go over. And this can get quite complex, especially when I find that people get a little bit confused. For instance, if I had to change this sum, and instead I had to write it backwards, then people have to sit down and think about what this means, even though these two mean the exact same thing. So in both of these cases, B is still greater than A, because in my explanation, the mouth is open to the B in either case. But like I said, whichever way works for you, that's great. As long as you know it, that's entirely fine. So let's go through these. And we have, right, so we have, for instance, this one means 1 is less than 4. And we know that 4, and this is what I was explaining, and draw another number line down here so we don't have to keep going back up to that one. I personally prefer to draw my number line instead of going across. I prefer, like I did in the example, just not to draw it going down. And the reason why I do that is because it's a bit easier to see which one is larger than which. So we obviously know that 4 is greater than 3, which is greater than 2, which is greater than 1. But where it gets a bit confusing is for the negative numbers. And here we can easily see that -1 is greater than -2, which is greater than -3, which is greater than -4. Now, if I use examples, for instance, like that one, that are oversimplifications, just as a background, something that you may not know, I used to be a teacher at Frederickston Secondary School. So I have learned over a long period of time how to break things down really, really simple, which is why I've been put to teach this class. So that's just a point to note. So, right, often we use the simples, sorry, I was here. So 4 is greater than 1 in the same manner that, for instance, 2 is greater than -2. And we'll write that as 2 is greater than -2. Often we use the symbols less than or equal to or more than or equal to, which is here, less than or equal to or greater than or equal to. And only one of these statements have to be true. So by that they mean it can be, if I write this, only one of these statements have to be true. Obviously 5 is not equal to 7. The equal part of this symbol is the lower part there at the bottom. But obviously 5 is not equal to 7, but 7 is greater than 5. So even though this has less than or equal to, the less than part is the only part that has to be correct because 5 is less than 7. That's what they mean by only one of these statements has to be true. Same thing here. I have 4 is less than or equal to 4. Obviously 4 is not less than 4, but it is equal to 4, and therefore the statement is still true because one of these statements are true. So moving along, we can say that both A is greater than or equal to -5 here because, because I know is greater than 5. And that -1 is greater than or equal to -1 is true. And this is still true, even though -1 is not less than 1, they're both equal to. So I'll be looking at that part, they're both equal to. From our line above, we can see that 0 is to the left of 2, which means that 0 is less than 2 because 0 is to the left. So as we go this direction, remember the numbers are getting smaller. So each number that you reach in this direction, so let's say I had to choose 3, for instance, will be less than any number that comes before it, any of these numbers that come before it. All right, if I had to use any of these numbers over here, these numbers would be greater than all of these numbers that come to the left of it. And like I said, I prefer this number line because it ranks them in order from smallest to largest, with largest being at the top and the smallest being at the bottom. And it's a bit easier to see. So 2 is to the left of 4, which means 2 is less than 4. These compound statements can be visualized as 2 is between 0 and 4. So symbolically, we can write 2 is between 0 and 4. It is more. 2 is more than 0, but less than 4. Do we understand that statement? The last one?
Yes, ma'am.
Yes, please.
Okay. In general, if x is between A and B, we write that x, so whenever we use both of these symbols, and they should always be in the same direction. So as in either like this or like this. It doesn't make a difference. But if it's between A and B, then we normally write it like this. So let's say, for instance, I had x is less than -2. Sorry, it's greater than -2, but it's less than 2. This means x is between -2 to 2. I cannot write it like this. I cannot come here and put hold on. I can't do this. Right? That's not correct. They should be going in the same direction. So, and what this would mean on a number line, for instance, is that x is any value between here and here, this portion. That's what this statement means, being between -2 and 2. So that's the reason why I can't, well, not that I can't, I shouldn't put this as a more than sign, because it wouldn't really make sense. It wouldn't represent the term between. All right, so I hope that's clear. If I have x is greater than or equal to y, it can also be read as x is at least y. This means that, so that word at least is important. This means that x is equal to y or is greater than y. So at least means equal to or greater. Now, if you continue in economics or in any kind of quantitative field, the terms at least and at most are two terms that you need to understand very, very well. If I have, they're going to come in quantitative questions a lot. So let me wrap this up. If I had, for instance, x is greater than or equal to 3, this means that x is at least 3. That means 3 or more. So if I had to do that on my number line, I would find 3. And that means x is this value 3 or more, which means it could be 3, 4, 5, 6, 7, 8, 9. That's a very, very, very important concept to understand. So at least means that value or more, whereas at most, let me go back down. At most means that number or less. So if I said P is less than or equal to Q, that is read as P is at most Q. That means that P can be Q or any number less than Q. So for example, if P is at most 5, then P can be 5 or any number less than 5. And I'm going to show you that on your number line. Let me do another number line here. The higher number line, this is 0 and this is 5. P being at most 5 means it's 5 or any value less than. So just to recap that, if I want to say x is at least 1, I will write that as this. If I want to say that x is at most 1, I will write that as this. And that's something that we need, like absolutely need to remember at all times. I was doing a program out to last year, a graduate program in, microeconomics. And there were several people who did not understand the meaning of those two terms. And as you get more technical, the value of understanding that becomes a whole lot greater, even though it seems as simple as it is. So just make sure you memorize that from now. So we have some statements here in words. X is less than or equal to 6. Less than or equal to suggests we have both our less than and equal to sign, which is good. X is positive. If X is positive, it means it has to be more than 0. It means when you look at your number line, you don't want any part down here, which means you want it to be 0. You want it to be above 0. So just a point to note as well, 0 is not positive or negative. 0 is not a positive number, it's not a negative number. So you can't write that x is positive and write that x is greater than or equal to 0. It has to be the numbers above 0, which are these numbers. So that means that x has to be more than 0. Is that clear? You understand?
Yes, ma'am.
Yeah.
Yes, please.
So how will you rate that x is negative?
X is less than 0.
Correct. So negative will be x is less than 0. All right. Now we have C is at most 3, and at most, remember, means 3 or less. So that means you should be using your less than sign and your equal to sign. Is less than or equal to 3? Yes, please.
Excuse me. Someone in the chat is saying no. I'm guessing they don't understand.
Pardon me?
Someone in the chat is saying no, but they don't understand.
Okay. Can they clarify exactly which part they don't understand?
Ma'am, she's saying everything you just went over.
Oh. Are you talking about what is in the table specifically? Because I can't go back over from the on the top of this page.
She's saying
X is greater than Y.
Okay. If it's just that one person, ask them to contact me afterwards because I think the majority of people get it. If they don't, you will have to say. But I have to move on to finish this lecture. So I could explain that to you one-on-one.
Oh, she said the table.
Okay, the table. So, all right, let me wrap this up. So we have x is less than or equal to 6. And we know that this symbol at the top here is the less than symbol, this one. We know that the other symbol at the bottom is equal to, so that's less than or equal to 6. X is positive, means that on our number line, we do not want any of these negative numbers. We only want the positive numbers, and they just said 0 is not positive or negative. So we can't say that is the values that are, for instance, 0 and greater, we cannot include 0. So that means to get x is positive, that has to be x is greater than 0. For x to be negative, then x would have to be less than 0, not less than or equal to, just less than 0. And if it's just less than 0, it represents all the numbers that are under 0. Anytime I give you a question and I tell you it is just less than something. So let's say, for instance, I wanted to show you x is less than, let's say, 4. So the answer for this would have to be all the numbers that are less than 4, and it cannot include 4. So the answer to this would be, for instance, 1, 2, 3. And it has to stop there because if it's less than 4, it does not include 4. So let me show you that again on a number line. Let me rub this up, make this look a little better. Somebody has gone there, mate. Whoever it is, it will need to turn it off, please. Okay, let's hear the background started. All right, so let me just highlight that again. So if I say, for instance, what about some of this? If I say, for instance, x is less than 2, then that represents all the numbers that are below 2. But because there's no equal to sign like that, it means it does not include the number 2. So my answers for this would be -1, 0. Sorry, let me go again. It would be 1, 0, -1, -2, and so on, right? And for instance, I gave you a question and I said, x is greater than 3. Then it would include all the values from above 3, but not including 3 because there's no equal to sign. That sign at the bottom, that equal to sign tells you include 3 in your answer. So if I don't have that there, like how I have it now, the answer for this would be 4, 5, 6, etc. Right? If I change that and instead I had x is greater than or equal to 3, then my answer would be 3, 4, 5, 6, and so on. Do you understand the difference?
Yes, please.
Yes, please.
Somebody said something. It ain't her.
No, I was saying that the young lady in the chat said she got it.
Okay, good. All right, so then we had here C is at most 3, and we understand that that means 3 or less. So that means we would have to include 3. So the answers for this being 3 or less means that it would be 3, 2, 1, 0, ... and so on. Then we have x is not less than 2. All right, So D is not less than 2. If D is not less than 2, what does that mean? Anybody can tell me?
Would it be that it's greater than?
Correct.
Equal to.
Greater than or equal to. Correct. So if it's not less than 2, that means you don't want any numbers that are less than. You don't want 1, you don't want 0, but it could be 2 or more. That's what that means. So not less than 2 or at least mean the same thing, right? So just bear that in mind. Not less than is the same as at least. And at most is the same thing as not, so that you can make that note, not greater than. Okay, so right. It's easier to understand it on a number line. If I tell you not less than 2,
Ma'am,
you don't want, yes please?
can you repeat not less than 2 is the same thing as at least, right?
Yes.
Okay, thanks.
Yeah. So not less than 2 means I don't want any of these values here that are under 2, which means it's 2 and up. If I say not more than 3, it means I don't want any of these values here, which means it can be 3 and down, right? So I think we understand that. So now we have intervals. Let's see how much more we have to go. Okay, we almost finished. All right, so if x is a real number on a real number line, the following are examples of intervals on which x is the variable. So for instance, if I want to say x is less than a, what's important here is this little circle here. This circle can either be open, which means you can see the inside of it, or it can be closed, which means it'll be a filled in black dot. If I just have x is less than a, this less than goes in the direction of the negative numbers, or the direction of the smaller numbers, and this part here is open. As opposed to, if I wanted to say, let me show you, if I wanted to say x is less than or equal to a, it would be a closed dot, filling that in as much as I can, and going in the same direction with a. So let me show you what this actually means. If I have a number line, I promise you that my handwriting only looks like this on my tablet, and I don't write this badly in real life. So if I have, for instance, this is a 5. If I have, for instance, let's do x is less than 3. If I had to do that on this number line, I'll find 3, I'll have an open circle, and I'll put a line, or some people do this. They either do it on the number line and carry it that direction, or sometimes they raise it a little bit above the number line, and you will have an open circle here at the top and a line going that direction to show that this is x and it is less than 3. Okay, so they normally don't put the x up there, so let me move that. You will put whatever the value is that is less than, but what's important is that little circle. If I wanted to put, for instance, let me move that now. If I wanted to put x is less than or equal to 3, I'll have a closed dot on the 3, and I'll put that line showing that it is less than. So remember, less than is this direction, more than is that direction. Okay. If I show you, so if we have down here, x is greater than or equal to a, which is given here. Again, you see the closed dot here, as opposed to the open dot they had it here. So if I wanted to show, for instance, If I wanted to show x is greater than, let's say, -2, if it doesn't have that equal sign at the bottom up here, then it's going to be an open dot on the 2. Sorry, very foolishness. Open. An open dot on the 2 and that direction. That open circle means I do not include the number 2 because it said it's greater than it. It doesn't say it includes 2. In order for it to include the value 2, it has to have that line at the bottom that means it's equal to, which means I'm including 2 in the equation. All right, if I had x is greater than or equal to 2 now, I will have a closed dot, and that means I'm including the number 2. And I also go that way. If I wanted to put that x was in between 2 terms, so in between a and b, I will have 2 dots representing the different numbers, but I have to look at the signs. If one of them doesn't have, if one of them is just less than or greater than, it will be an open circle. If one of them is less than or equal to or greater than or equal to, it will be a closed circle. So let's say I had, let me do one. Let's say I wanted to say that x is between 3 and -1. No, I'm just saying it's between. I'm not saying it is equal to. Both of these are less than signs. So that means I'll have an open circle on the -1, an open circle on the 3, and my answer will be between those 2. If, however, sorry, this wasn't equal to, that is the answer for that question. If, however, I had to change this, and I had to make these equal to, these instead would become closed circles. And let me show you the difference to the 2 answers. So let me write the other question back here. At first I had this. The answer, and we normally put them in set notation. The answer for the first one would be -1, 0, 1, 2, and 3. The answer for the second one would be 0, 1, and 2. Because this one here does not have any equal to signs and therefore does not include the values 1, -1, or 3. But this one does. Therefore, I include the values -1 and 3. All right, absolute values. I explained this earlier. The absolute value of a real number A is denoted by this symbol. I didn't tell you this symbol, but this is your symbol here. And it's defined as the distance between 0 and the origin. So for instance, if I wanted to say the absolute value of -3, I will write it as that. Those 2 lines mean the absolute value. That's also called the modulus. And that just represents the number without any kind of direction. It just represents the number 3. So it's defined as the distance between, is more of a distance in terms of than a direction. I don't know if y'all would be familiar with vectors, for instance. This just tells you, let's think of it as like jumping on your number line. This answer tells you how much times to jump in each direction from 0. Whereas if I had -3, this tells me to jump in the negative direction or to the left. And the +3 will tell me to jump from 0 to the right. But the absolute value just gives you the amount of times you jump. It just gives you the quantity or the distance away from the origin or away from 0 as opposed to the direction. Your negative sign will give you that direction. So that's just all the absolute value is. So for instance, if I had to do the absolute value of these 2 terms, the absolute value of 3 would be 3. The absolute value of +3 would still be 3. So it's kind of almost like just taking the negative off of the, taking the signs off of the numbers. That's all the absolute value does. So for instance, here they were using -4 and +4 and finding the absolute values of those. -4 is here, +4 is here. They're still both 4 units away, 4 jumps are 4 units away from the origin. And therefore, that's why the absolute value of -4 is equal to 4 and the absolute value of +4 is still equal to 4. So I hope that that's clear. So when you hear me speak about absolute value, I just mean...
Can you go back over that for me, please?
Sure. So I was just saying the absolute value is just the distance away from the origin, whether it is positive or negative. So here I have a -4. The origin is 0, right? So -4 is still 1, 2, 3, 4 units away from the origin. So the absolute value of -4 is the same 4 units. That's the same as the absolute value of +4 now. If I count from the origin is 1, 2, 3, 4 units. And therefore the absolute value of a +4 is still 4. So is the absolute value is just the distance from 0 to the number, ignoring what the signs are. Right? So if I ask you for the absolute value of -2, it would just be 2. If I ask you for the absolute value of 0, it'll be 0 because it doesn't move. If I ask you the absolute value of +5, it would just be 5. So just think of it as a number without the sign. So the absolute value of a number is always positive or 0. So for instance, so that's what this here means. This notation means this reads the absolute value of any number x is always positive or 0. Well, we know, right, or 0. It could be positive or 0. It has to be greater than or equal to 0. The reason for that is, like I said, the absolute value of 0 is 0. And the absolute value of any number other than 0 has to come out to be a positive answer. The absolute value of -1 is 1. The absolute value of +1 is still 1. So your answers for your absolute value must always be greater than or equal to 0. The next rule is next rule is a number and its negative have the same absolute value. So if I have a number x, the absolute value of that is the same as the negative version of itself. So that means the absolute value of 4 is 4, and the absolute value of -4 is also 4. The number and its negative has the same absolute value. In addition to that, the absolute value of a product, and we know this means that they're multiplying. The absolute value of a product is the same thing as when the absolute value is the same thing as the product of the absolute values. So that means if I'm finding the absolute value, and remember these little things here is what makes the absolute value, right? It's what notates that you're working on the absolute value. So the absolute value of -2 multiplied by 3 is the same thing as finding the absolute value of -2, finding the absolute value of 3, and then multiplying your answers together. Right? So let me show you how that looks a bit more broken down. These are some properties that you need to know. So if I have the absolute value of -2 multiplied by 3, and you need to break down this notation also, it will be the same as, let me write it under here. It'll be the same as, I'm going to put back my absolute signs, and I'm going to work out the inside. You can treat absolute value, the lines that represent absolute value almost like brackets, because you can get them in the middle of a sum. You can actually use them, you will get them in like a bottomless sum or something. So you can think of them like brackets in terms of the order operation. So you can work out inside of your brackets / absolute value symbols, and you will work out the inside, and you'll get 2 multiplied by -2 multiplied by -2 by 3 is 6, is -6. So I'll put -6 here, and I know the absolute value of -6 is just 6. That's the same thing as if I had to work out the absolute value of -2 multiplied by the absolute value of 3. So I will get here the absolute value of 2 is 2. The absolute value of 3, sorry, absolute value of -2 is 2. The absolute value of 3 is 3. And I'm still going to get out 6. So that just goes to show you the absolute value of -2 by 3 is the same as the absolute value of -2 multiplied by the absolute value of 3. I want you to get accustomed to understanding these properties and anything really in math that is written in algebraic form. And it's just done like that so it can represent a general rule. And this term here just means the absolute value of any term A multiplied by B is equal to the absolute value of A multiplied by the absolute value of b, and those a's and b's, you know, just represent any possible numbers that I could choose. Similarly, the absolute values of two terms, two numbers being divided is the same as working out the absolute value of each individual number and then dividing it. So if I had, for instance, the absolute value of, let's say, -4 over 2, if I did that, this will be exactly the same. Well, let's work out this one. We're going to work out that. And let's do the property result, which should be that the absolute value of, sorry, just this property, the absolute value of 4 divided by the absolute value of 2. So if I had to work out this one over here on the left, I'll get the absolute value of, we'll have to work out the inside. Remember, because I said we can treat these like brackets, so let's work out the inside. -4 divided by 2 is -2. And I know the absolute value of -2 is just 2. That's entirely the same thing as if I worked out the absolute value of 4. I know I'll get 4. Work out the absolute value of 2. I know I'll get 2. And then divide and I'll get 2. So they work out to be the same thing. So again, the absolute value of two terms being divided is the same as working out the absolute value of each term and then dividing them afterwards. So that's another property to know. Okay. So we have example 5 here.
Can you repeat?
Which part?
The last part.
I just said the absolute value of two terms being divided or finding the quotient is the same as if I find the absolute values of those individual terms and then divide them afterwards. That's all it was. So we have, for instance, we have example, find the absolute value of just 5, and it would just be 5. 5 is positive, so you just remove the absolute sign. We have the absolute value of -6. Here the 6 is negative. You don't necessarily have to do this, but you will know the absolute value of 6. It's just 6. You have here the absolute value of 3 minus 8. And remember I told you can work those out in brackets. So you will have 3 minus 8. And you'll keep writing about your absolute signs until you work out the absolute value of your inside part. So I'll get -5 for the inside part. And then I have to work out the absolute value of -5, which is just 5. Right? Like I said, this part here isn't really necessary, putting that extra negative to get rid of it. So we have the last example now, which is the most important one. We have x minus 2, since we do not know the absolute value of x minus 2. Now, remember to your algebraic terms represent any possible number, so you have no idea whether x is a positive number or a negative number. So because of that, you have to work out two answers. Because x minus 2 could either be a positive value or it could be a negative value depending upon whatever x you choose x to be. So we can have two answers. The answers, oh shoot. The answers would be, if x is positive, then the absolute value of x minus 2 would just be x minus 2. However, if x minus 2 is negative, then the absolute value of x minus 2 would be to put a negative symbol on your x minus 2. So by that they mean, this is kind of what was happening here.
Ma'am, it got lower.
I can't hear you anymore.
Can you hear me now?
Yes, please.
Okay. All right. So just to make sure we understand this last part, what I was saying here that you don't necessarily have to do is that when you are doing the absolute value of a negative number, they're almost thinking of it, text is almost thinking of it as if you had to put another negative to cancel out that negative, right? Even though we know the absolute value of negative 6 is just 6. Similarly, here, they did it here again. You know the absolute value of negative 5 is just 5. But if you wanted to work out mathematically, you could put a negative in front of that 5 to cancel them out so that they will become a positive 5. Everybody understands what I mean by that? So for instance, the absolute value of negative 7, you can, even though you know the answer is just 7, and that's entirely fine. When it comes to algebra, it may be important to note that if I want to work out the absolute value of 7, I can put a negative sign on my term in here. A negative on my negative 7. And that would give me a positive 7. And the reason I added in this negative here is so that it will cancel the negative here and just give me a positive value, because I know that my absolute value should be positive. So if we understand that, then we should be able to understand here, if we have two possible answers, if the x minus 2 is a positive term, then the absolute value of x minus 2 will just be x minus 2. But if the x minus 2 is a negative term, then to cancel out the negative, you would put a negative sign at the front to be able to cancel it and get back a positive term. So these are two terms. So when you put that negative, you have to use a bracket so that you apply it to both terms, and therefore the signs would switch. So let me show you that in an example. If, for instance, x, let's say, was equal to, go on Jamboard. So we were finding the absolute value of x minus 2. Now let's say, for instance, x is 3. Right? And in that case, 3 minus 2 will be 1. Therefore, if x minus 2 is 1, then the absolute value of 1 will just be 1. That's fine. However, let's imagine that x instead was, let's say, minus 5. And then I have to work out the sum, which is x minus 2, right? And I'll get minus 7. So instead of just having x minus 2, the answer would be find the absolute value of minus 7. Now we know the absolute value of minus 7 is 7. However, what's the working that you should mathematically do to be able to get there? It will be the same as if you had applied a negative number to this minus 7. A negative term, sorry, negative symbol. So if I take a negative and I put it on my minus 7, you just put it in brackets so it looks better, then I will get the positive 7 that I know the answer is. Does everybody understand what I mean by that? Or have I lost anyone?
Yeah, I lost.
Mommy lost.
Mommy lost me.
Okay. All right, let me go again. Let's go back from understanding we understand what absolute values are, right?
Yes.
So if I were to tell the absolute value of 5, I know I would just get 5. If I work out the absolute value of negative 5, that answer will be what?
5.
Just 5. What I'm saying to you, however, is right, you have to be able to write that down mathematically in terms of some form of working. And the working would be that if the number is negative, what I want you to do is to add a negative so that you can cancel out the negative sign that's already there, and it will become the positive 5 that you know the answer is supposed to be. Because, well, not be positive 5. You know that your answer is supposed to be a 5 without any signs, positive or negative. Therefore, what you need to do in your absolute value is that this negative here, it needs to go. The only way that it can go is by adding another negative sign so that it can cancel, because you know that two negatives cancel each other out. Do we understand that?
Yes.
Right. So the only mathematical way that you can work out an absolute value is to take your term, whatever is here, which is the -5, and put another negative on it. I just put a bracket here to show that this was my number instead of my absolute value here, and that I'm putting another negative on it, which is right here. So when I do that, these two I know will cancel out, and my answer would just be 5. I've just done in 2 steps what you already know in 1 step, that my absolute value of -5 is really 5, but I'm just showing it mathematically. In the same way, if I had the absolute value of -a, I know that that answer is just a, but mathematically working it out, I should take that -a and I should apply a negative so that these two are canceled and I would just get a. Do we understand that?
Yes, please.
Yes. So going back to the question that I had, if I have the absolute value of just a, then I don't know what a is. A could be a positive number, a could be a negative number. I have no idea. So I have to have 2 answers. Somebody's mic is on. I have to have 2 answers. If a is positive, like 3, 4, 5. Let's say a was 3. My answer would just be 3, correct? So if a is positive, the absolute value of a is just a. Just like if I change this and I said, if a was 3, the absolute value would just be 3. So we understand that. However, if a is negative, then the absolute value of a, so let's imagine a is a negative number, right? Then a negative number, for instance, could be -2. If a is -2, the only way to mathematically turn that into an absolute value will be to take your -2 and put a negative sign on it. So we get our signs canceling. So I'm saying if a is a negative term, the only way to mathematically turn this a into a term that has no sign would be to put a negative on that a. Do you understand what I just said?
Yeah.
Yes, please.
Right. So a is just a placeholder for whatever I want it to be. In this case, if I want it to be a negative number, it could be -2, it could be -10, -11. So if for instance, a is really -11 and I have a negative a like how I have here, let's say a is -11, then if I have a negative sign here already, and a is really -11, would my 2 signs here cancel out and I will get +11?
Yeah.
Good. So that's what I was trying to explain in the other question. Where have we gone? So if we have here, we have x -2. So let me do that one again. I'm going to ask you, if you all don't mind, can we continue for another 10 minutes? Is that okay for everybody?
No problem.
Do you have another class?
That's okay.
Anybody
No
has
problem,
another
ma'am.
class? Besides those that have me
10
tutorial?
class.
I do.
I got 16 class, but I can stand it till the next 10 minutes.
All right, well, just 5 minutes then, 5 minutes. So if we're working on the absolute value of x -2 that we had there just now, we have 2 answers. If x -2, that whole sum, and to use that whole sum, we use a bracket. If x -2 is positive, then we know that the absolute value of x -2 is just equal to x -2. That doesn't change. But if x -2 is negative, then we will have that to work out the absolute value of x -2. If this whole thing here is a negative value, if the answer comes out to be a negative value, what I would have to do is I'll have to put a negative on that bracket so that the whole answer, I cancel the sign. So by that I mean, suppose x minus 2 comes out to be, if that's negative, so suppose that's negative 11, then it means that if I have a negative here, and this is really minus 11, those two words cancel. So I put my negative here as a precaution, right? Yes, please?
You're supposed to got a plus sign or negative sign to make it positive. X minus 2.
I haven't worked, you mean the two part? The part with the two?
Yeah, right there. Where you got the bracket?
It's supposed to be negative.
Where you got plus?
I don't have a plus sign. Where you mean? I'm very confused.
Oh,
She means the one at the top.
Mom, you have a plus sign in the bracket to the bottom. You got minus
Sorry.
x plus 2.
Right. Okay. Sorry, I'm going one step ahead. Right. So the next step now is, if we understand this part here, is that when we take this out of the bracket now, we have to multiply out our signs. So you know these two will give you minus x, and you know the negative and the negative here will give you a positive. That's where I got that from. Okay?
Okay, thank you.
All right, let me just check. So we have some cautions that I just want to run through here quickly in the last few minutes. I was hoping to get to unit 2, but I guess we'll have to start out next week. To compute an expression, and I cannot explain this already, but to compute an expression like this, your square root symbol has to be considered almost like your square root symbol is over two terms. If you had a square root of 7 squared plus the square root of 51 squared, I am squaring those numbers individually, but once the square root symbol is over both of them, and you're trying to find the square root of two numbers at the same time, then you have to put these in a bracket. So they show you here, if you don't have the brackets, the calculator will only compute the 7 squared, the square root of 7 squared, and then add on 51, and it will not compute the square root of 51. As opposed to if you use the brackets, it will work out the answer for the inside, like here, like 100, and then find the square root of that answer afterwards. A common, yes, it's? Yeah. A common mistake is to write an expression such as 2x all raised to the 5 as 2x to the 5, and this is incorrect. If you have a bracket, it means whatever is on the outside must be applied to both terms in that bracket. So 2x raised, all raised to the power 5 means 2 to the 5. 2 to the 5 and x to the 5. It does not mean 2 with just x to the 5. That would be incorrect. And additionally, the rules of indices only apply when the bases are the same. They will not apply in situations such as x squared multiplied by y cubed, as long as the bases, and bases I mean the bottom letters or numbers or whatever they are, if they're not the same, you can't go ahead and add these powers. Same thing here. If they're not the same numbers at the bottom, then you can't go ahead and subtract those powers for division. When C and D are non-zero and n is not equal to 1, then C plus D is not to the n is not equal to C to the n plus D to the n. So we had some rules. We understood that, like for instance here, I just explained that 2x all to the 5 means 2 to the 5 x to the 5. That only applies when the terms are multiplying, like here. If we have them adding, like here, you cannot just go and put that power onto each term. That's not correct. And we are going to deal with what the answer for this should be in next lecture. The exponent laws only deal with products and quotients, as we just explained. So this would work also if I had 2 over x to the 5. That answer would be 2 to the 5 over x to the 5. As long as it's multiplication or division, products or quotients, you can do that. Common errors with addition. I think you can go through these on your own. I don't think I need to explain them. But yeah, these are common errors that people make with addition, and all of these, just to clarify, are wrong. Okay? So just note that. So you can look through them on your own time, and just know that these are things that you cannot do. All right, so we're going to call it a day for today's lecture, and I will post Unit 1 later and your tutorial assignment for next week a bit later tonight. Any
Thank you,
questions?
ma'am. Good night.
Thank you.
No, I will not be able to post the recording tonight. For these lectures, the recording takes a little while to upload. So it'll be posted by tomorrow, but I can't tell you tonight.
Excuse me, ma'am.
Yes, please?
I've been having trouble posting my second tutorial, so would it be okay if when I get the third tutorial, if I can post both together?
You need posting them?
To send them to Mr. Julian. I wasn't able to send the tutorial to him.
He asked you to send them to him, or is this for the practical?
This is for the practical. Yeah, I think we're supposed to send in all of the tutorials, right?
Not tutorials, the practicals.
Questions, the tutorial questions, that's what I mean.
No. So you have tutorial questions and practical questions, which are two different things, two different assignments altogether. So the practical, you will have to submit. The tutorial assignments you don't submit, you just go through those in your tutorial session. But your practical ones, I would advise you to still send it in because you get participation marks for those. If you don't send anything, you don't get a mark.
All right, thank you.
Hi, ma'am.
Yes, sis?
Question, is there a textbook that you can recommend?
To be honest, any CSC textbook is fine. The one I prefer is called the Tues, Toolsie. And that has two textbooks. Unfortunately, I can't find that online, and you will not find any textbooks for CXC Math in the Cape Hill Library. You will have to go to the National Library or something, or just look around at in any bookstore for a CXC textbook, and you would find that one. But they can be a little bit costly. But you could look around. But anything that you don't understand, you can always Google it. As long as you know what the topic is, there is a whole set of YouTube videos on all of these topics already on YouTube.
Okay, thank you.
Excuse me, ma'am.
I'm listening.
When I email my practical assignments, it doesn't seem like they're seen, and then I get a non-graded or a missing assignment because I'm not able to post them on e-learning. And I was wondering if it is that he wasn't checking the emails, or if it was that my emails just didn't go through to him.
Okay, can you give me your name?
Pardon?
What's your name?
Sarah Douglin. SARADOUGLIN.
Okay, I will inquire.
Ma'am, I had the same problem for my first practical as well.
All right, let me get your names. But you should be checking them. But I did think he said, is it that y'all don't have access to e-learning, or you just have problems posting it?
I just have problems.
I had problems at first. I got it started out, but at first I had problems, so I had to email my work to him via my personal email.
So do I.
So it's saying that I have not uploaded my work, and it's saying that I am late, and I didn't get a grade or anything for it.
So you can't send it from your Cape Hill mill either?
Pardon?
You can't send it from your Cape Hill mill?
So I can still send it?
I think you can, as long as you have records showing. It would forward the email showing that you submitted it within any time frame you were supposed to.
Yeah.
That shouldn't be a problem. But what I know that happens often is even with me, when I get an email from some person who does not have a Cave Hill mail, sometimes it goes to junk or I don't get it at all. So
That's what I was thinking.
Right, I'll always use your Cave Hill mail. But it could be a case where he didn't check them, so I will verify. Just give me names. The first person was Sarah Dublin. For the
Could
other,
you send mine as well, please?
pardon?
I have the same issue as well. Annalisa Joseph.
Annalisa Joseph.
Danelle Osborne.
Pardon?
Danelle Osborne.
Renelle? Can you spell that for me?
Janelle. Osborne. You.
Okay. So Jesse C. I will chat. Let me just write them all on that. Chat with Julian. And this would have been only for the last practical?
Not the last one, the first one.
Mine is for both.
Mine is for both.
So that's Sarah.
Mine is for the first one.
Sarah and Annalisa is for both?
Yes, please.
It could also be a case where he did see it and maybe forgot to put in remarks on e-learning, because that's a possibility. So if e-learning doesn't see a grade, then he didn't, but I will double check for you and I will get back to you on that.
All right.
Okay, thank you, ma'am.
All right, no problem.
Thank you.
No problem.